We start by noting that minus half is equal to minus of cos of pi upon 3. And since cos is negative in the second quadrant, this can also be expressed as cos of pi minus pi upon 3 or cos of 2 pi upon 3. Similarly, root 3 upon 2 is equal to sine of pi upon 3. And since sine is positive in the second quadrant, this can be expressed as sine of pi minus pi upon 3, which is equal to sine of 2 pi upon 3. Therefore, minus 1 plus minus I root 3 upon 2 can be expressed as cos of 2 pi upon 3 plus minus I times sine of 2 pi upon 3. Now we are given the equation minus 1 plus I times root 3 upon 2 whole raised to the power n plus minus 1 minus I root 3 upon 2 whole raised to the power n is equal to 2. Substituting the results obtained above, we get cos of 2 pi upon 3 plus I times sine of 2 pi upon 3 whole raised to the power n plus cos of 2 pi upon 3 minus I times sine of 2 pi upon 3 whole raised to the power n is equal to 2. Using the Mauve's theorem, the left hand side can be written as cos of 2n pi upon 3 plus I times sine of 2n pi upon 3 plus cos of 2n pi upon 3 minus I times sine of 2n pi upon 3, and this is equal to the right hand side, which is 2. On the left hand side, the imaginary terms cancel out, and this equation can therefore be written as 2 times cos of 2n pi upon 3 is equal to 2. 2 cancels across the left hand side and the right hand side, and on the right hand side, note that 1 can be expressed as cos of 2m pi, where m is a natural number. It therefore follows that 2n pi upon 3 is equal to 2m pi. 2 pi cancels across the left hand side and the right hand side, and therefore n is equal to 3 times m, where m is a natural number. And this is the required answer.